Hello everyone. Today we will be discussing about the topic of atomic structure. So before talking about atomic structure, let's first discuss about what is an atom. So if we go by definition, then the smallest particle of an element which may or may not have an independent existence, but the point to be noted here is that it will always take part in a chemical reaction. Such a particle is known as atom. For example, we have hydrogen atom denoted by the symbol H. We have oxygen atom denoted by the symbol O. We have carbon atom here which is denoted by the symbol C. We have chlorine atom here denoted by the symbol Cl, and many more. For example, let's take a few more examples. Okay, let's say we have an atom of potassium that is denoted by the symbol K. Why K? Why not P? First thing is that there is already another element which is known as phosphorus, which starts with P. So you could have asked that why not any other element with any other letter along with P could have been used as potassium. So the main thing is that the Greek name of potassium is kalium. So therefore the letter K is used. Similarly, iron has Fe because the Greek name is ferrum. Then calcium has Ca, cobalt has Co, nickel has Ni, sulfur has S, then argon has Ar, helium has He, nitrogen has N, beryllium has Be, sodium has Na because the Greek name for sodium is natrium, magnesium has Mg, and etc. 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 So this is what an atom is. So always remember that an atom may or may not have an independent existence, but it will always take part in a chemical reaction. Next we come to molecules. Now what is molecule? The smallest particle of a pure substance. Now what is a pure substance? A pure substance is something in which all the constituent particles are of the same kind. For example, if we take oxygen gas. So in oxygen gas, all the particles will be of oxygen. Basically, all the molecules will be of oxygen. If we take distilled water, then it contains only the molecules of water. If we take carbon dioxide gas, it will contain only the molecules of carbon dioxide. So pure substance is something which has all the constituent particles of the same kind. Okay, so the smallest particle of a pure substance which always has an independent existence is known as a molecule. So you got the basic difference, I guess, between a molecule and an element. The basic difference is that a molecule will always have an independent existence, but an atom may or may not have an independent existence. Just take a few examples for molecules. That is, hydrogen molecule is denoted by H2, carbon dioxide molecule is denoted by CO2, sulfur molecule is denoted by S8. Similarly, we have phosphorus molecule denoted by P4. We have nitrogen denoted by N2. We have oxygen denoted by O2. We have water denoted by H2O. We have sulfur dioxide denoted by SO2, and so on, so on, so on. Now, when we were talking about this independent existence, so let's talk about this point in here, that it may or may not have an independent existence, this atom. So there are some elements whose atoms exist independently. For example, helium. Helium is a noble gas, group number 18 of the periodic table, period number 1. Similarly, we have neon, we have argon, we have krypton, we have xenon. These all elements exist as monoatomic molecules, means their atoms are chemically stable to exist independently. But at the same time, we have oxygen, hydrogen, whose atoms are not that stable so that they can exist independently, and therefore they combine with other elements. Two hydrogen atoms combine to form a hydrogen molecule to exist independently, means the molecule will exist independently, not the atom. Then two atoms of oxygen combine to form oxygen molecule to exist, and so on and so on. There are many more examples. So now let's talk about the history of this topic, that is atomic structure basically. So atomic structure, in around 600 BC, I mean nearly more than 2600 years from now, An Indian philosopher named Maharishi Kannad, he stated that matter consists of small indivisible particles known as paramanu, which in today's days we know as atoms. And he also stated that two or more paramanus will combine to form anu, which in today's time we know as molecule. Let's talk about in a bit of a detail, okay? So he stated, let's suppose this is some element, I guess. Let's suppose this is some particle of an element. Now if we divide it into two, we get some piece of this kind. Now let's divide again into two. Again a smaller piece, again a division, again a smaller piece, again a division. We get again a smaller piece. In the same way, Maharishi Kannad said that if we keep on dividing this, some stage will come where further division won't be possible. It won't be able to be cut into more pieces. And that stage he named as Paramanu. So, the most important point which we have to understand from this Maharishi Kannad's contribution is that atoms combine to form molecules. I guess you would have understood from this part as well that H2 contains two atoms of hydrogen. Then carbon dioxide contains one atom of hydrogen and two atoms of oxygen. So atoms combine in order to form molecules. Then in around 400 BC, there was this Greek philosopher named Democritus, who also stated the same thing as Maharishi Kannad but in a different name. He stated that matter consists of small indivisible particles, which he named as atoms. So if the question is that who coined the term atoms, then the answer will be Greek philosopher Democritus, which comes from the Greek word atomos, which means indivisible or indestructible. Alright, so now let's talk about one of the most famous atomic theories of mankind. That was John Dalton's atomic theory. I guess if I'm not wrong, the exact year is 1806. So, and basically it's important to know that this was published in the 19th century. So what does the atomic theory proposed by John Dalton state? So the atomic theory proposed by John Dalton has these many points. So number one, it states that all matter in this universe is composed of fundamental particles which are known as atoms. Okay, all atoms means all matter in this universe, whether it be this pen or maybe this notebook, or maybe I have a clipboard beneath this, that clipboard, or maybe anything. Let's suppose I'm taking this mobile phone. Everything contains atoms. They are made up of fundamental particles which are known as atoms. Next point, he stated that atoms are indivisible and indestructible, which means that, for example, if we take an atom of hydrogen, let's suppose, we cannot cut it into two. We cannot cut it into more particles or divide into further more particles. This is what he stated. At present, we know that this is not true. Atoms can be subdivided. And he also stated that atoms are indestructible. That means an atom present cannot be destroyed by any physical or chemical change whatsoever. Okay. Third point, he stated that atoms of the same element are all alike in all respects. Which means, let's take an example to understand it in a more thorough way. Let's suppose we have atom of hydrogen. We have two atoms of hydrogen. So the two atoms of hydrogen will be the same in all respect. Means that their mass will be the same. Then let's suppose their density will be the same. Then if there is one more point which is not included in the theory, means in this entire 5-point thing, but he considered that atoms are generally spherical. Okay, so from the beginning of mankind, atoms are considered to be spherical only. So if they are spherical, then they will have some radius. So the radius of the atoms will also be same. The volume will also be same, and so on, so on, so on. And atoms, the next point he stated was that atoms of different elements will be different from each other. For example, an atom of carbon and an atom of oxygen will be different from each other. A carbon atom will have mass different than oxygen atom. We also know it in this way, that an oxygen atom is heavier than an atom of carbon. Then the density will also be different, volume of one atom will be different, and so on, so on, so on, many different things. Okay. Then one more point is here, that atoms of different elements combine in simple whole number ratio. This is the most important part of this entire point, is that they combine in simple whole number ratio to form compounds. Examples, let's take a few examples. That's CH4. So CH4 contains carbon and hydrogen atoms in the ratio 1:4. Let's take water. It contains hydrogen and oxygen in the ratio 2:1. Let's take carbon dioxide. It will contain carbon and oxygen in the ratio 1:2. There are other examples as well. For example, if I take a molecule of sulfuric acid, H2SO4. What it is? It is sulfuric acid. So the sulfuric acid contains hydrogen, sulfur, and oxygen in the ratio of 2:1:4. So see, the ratios are all whole number ratios. So these are the 5 points of John Dalton's atomic theory. I hope you have understood it till now. But these points could not be held for a very long time. Means this John Dalton's atomic theory nearly failed in all respects. It is not good to say failure. Let's better say it had drawbacks in all the points. For example, let's suppose the first point which he said, that all matters in this universe is composed of fundamental particles known as atoms. Now at today's time, we know that atom is not a fundamental particle. There are fundamental particles such as electrons and protons and neutrons. Even protons and neutrons are not fundamental particles. They can be further subdivided. So this point is wrong. Goes wrong. Then atoms are indivisible and indestructible. Again, this is also not true. In today's days, we have nuclear fission and nuclear fusion reactions in which atoms can be split. Two atoms can be joined together to form one. So this is also not true. Then atoms of the same element are all alike in all respect is also wrong. How? Now you will be asking, how is this wrong? So let's take the example of isotopes. I hope everyone knows what an isotope is. An isotope is an atom. Means isotopes are atoms of the same element which have the same atomic number. Repeat after me. Which have the same atomic number but different mass number. So if the mass number is different, then the masses of the two atoms are different. Similarly, if we say atoms of different element are different from each other in all respect, then that is also wrong. We have substances which are known as isobars. Isobars are atoms of different element which have different atomic number but same mass number. For example, if you take example of, let's suppose isotope example is protium and deuterium. Both are hydrogen, but protium mass is 1, deuterium mass is 2. Examples of isobars are, let's say for example, an atom of argon and an atom of calcium. Both have different atomic number but the mass number is same. Both have 40. Mass number is 40. So they are isobars, so they are not different. And then this point, that atoms of different element combine in simple whole number ratio to form compounds. This is also not true. In today's days, we know that we have polymers. Then the ratio of the atoms is not in simple whole number ratios, and whole number is also not true. There are compounds, for example, which have which are not in means we in this level we don't need to know about them, but still, just for example, Ni 0.98O, this is also a compound. This exists. See, Ni 0.98. So it is not in whole numbers. It is not in whole numbers. So all these points, as far as today's days are concerned, are not true. So I hope you understood this video till now. In the next video, we will be discussing about the fundamental particles of atom, the discovery of the fundamental particles of atom, namely electron, proton, and neutron. Thank you very much for watching.